Hi there. In this video we're going to look at volumes of prisms, and we're going to look at working backwards. So these are questions where you've been given the volume and you're being asked to find one of the missing lengths. Now there are two main sorts of questions you'll get that fall into this category. There'll be questions where you're asked to work out what the length is, which are slightly easier. And then there are questions where you'll be asked to work out one of the lengths on your cross section, on the front face, or on the face that's been stretched. Those ones are slightly trickier because you need to then calculate the area and then use the area to calculate your missing length. So there's two main types. We'll look at finding the length first, and then we'll have a look at how we do the slightly trickier ones where you're given a more obscure length to find. Okay, so let's have a look at our first example here then. So it's a prism, and this triangular face is our cross section. That's the face that's been stretched into 3 dimensions, and we're asked to find the length of the prism. So this is one of the slightly easier problems, but our general strategy for all of these problems is going to be the same. We need to think, what did the examiner do? What did the person writing the question do to get to this answer of 48 centimetres cubed? Well, because it's a prism, he likely used this. The volume is the area of the cross-sectional area times by the length. So what he did was he did the area times by the length, and his answer was 48. Now, the length is exactly what we're trying to find. This length here is x, and that's exactly what we're trying to find. But to use this, we need to work out the area. Now, fortunately, we're given all the information we need to know to work out the area of this triangle. So once we've worked out this area, then that gives me a quite nice equation that we can solve to work out. So let's have a look then at finding this cross-sectional area. So it's a triangle, it's a right angle triangle, so that height is the perpendicular height. So remember, the area of a triangle is equal to a half times by the base times by the height. And the base in this case is 4, the height in this case is 8. So we've got a half times 4 is 2, times 8 is 16. So I know that the area that whoever wrote this question calculated when they worked out their answer of 48 was 16. So I can swap that A with a 16. And now this is quite a nice equation that we can solve. We've got 16 times by something is 48. Now, some of you watching at home might be able to spot that straight away. If you can't, that's not a huge problem, because we know our method to solve an equation. We've got a number and we're timesing it by 16. So to get that number, we have to undo that. We do the opposite. So instead of timesing by 16, we're going to divide by 16. And if we do 48 divided by 16, you get 3. So in this case, x is 3 centimetres. Okay, so on to our next example. So in this one, I'm going to have a go at this question on the right. While I'm going through this one, if you have a go at this one, they're very similar questions, so they're very similar steps. At any point, feel free to pause if you need a little bit of time to catch up, or if you want to watch me do a step and then you do that, that's fine. But the idea is that by the time I get to the end of this one, you should have got to the end of this one with an answer that we can then check in a second. So, similar question to the previous example, we're asked to work out what the length is. So remember, the volume is the area times by the length. So when this question was being written, to work out this answer of 180, they worked out the area of this front face and the cross section, and then they timesed it by x. Area times by x is equal to 180. Now it kind of seems like we've not really done much in this step, but this is a really important step because it's going to focus us into figuring out what we need to do. So let's work out what this area is. So the area of this front face. Now, the area of this front face, this type of shape is a trapezium. Now in this one, it's been made a little bit obscure how we find the area of a trapezium because they've not, on the face of it, they've not given us the height of the trapezium. But what they've done is, they've been a bit cheeky and they've given us the height back here. So I know that because this is a prism, because it's the same all the way across, this length here is also 3, which then allows us to find our area of this trapezium. Now the area of a trapezium, if you remember, is the average width times by the height. Now the average width is a half times by the top plus the bottom, 4 plus 8. Remember, to find the mean of two things, you add them together and half them. So the average width times by that height times by the 3. Now 4 plus 8 is 12, and half of 12 is 6. And then 6 times by 3 is 18. So I know that my area is equal to 18. So at this point, if you need to pause the video to have a go at finding the area of your trapezium, feel free, because we're very nearly at the end of the question now. Okay, so the area of this front face is 18. So to get this answer of 180, the person that was writing this question did 18 times by the length, and they got an answer of 180. And now in this question, it's fairly easy to spot that x is equal to 10. But again, if you weren't able to spot that, if you do 180 divided by the 18, that's going to give you your answer of x equals 10. Yes. Okay, so hopefully by now you've managed to finish this question off. Let's go through and see what the answer is. So again, we'll start by working out what the area is, because remember, to work out the answer, they did area times by y this time, and they got their answer of 64. So let's work out what the area is. So the area of the trapezium, again, is a half times by the 2 plus the 6, the average width, times by the 4. Well, 2 plus 6 is 8, half of that is 4, times by 4 is 16. So then we need to think, the area is 16, so we do 16 times by something, times by y, is equal to 64. Now, again, you might be able to spot what that is. If you can't, we just divide by this 16, and that leaves me with y is equal to, well, 64 divided by 16, and 4 16s going to 64. So y in this case is equal to 4 centimetres. So if you managed to get that at home, well done, that's really good. Okay, so on to our next example. Now this one's slightly trickier, and this is one of the slightly more difficult ones that I talked about at the start, because we're told what the length is, and actually we're asked to find one of the lengths that we'd need to find this front area, the cross-sectional area. So there are a couple of ways you can do this. I suppose the most straightforward way is to just substitute all of this into your equation, and then solve that. Now that requires you to be fairly confident with your algebra. Or the other way to do it is to sort of methodically work backwards. So in this example, I'm going to go through both different ways. It's the same maths in each, it's just how it's broken down. So first of all, we need to think to ourselves, what did the person writing this question do to work out this answer of 63? Now again, they will have done volume is equal to the area times by the length. Now, in this case, we know that the length is 7. And we know that they got an answer of 63. What we don't know, and what we need to find, is the area. So at this point we can think, okay, what area must they have worked out for this to have worked? Okay, so what area must they have worked out this triangle to have for this to have worked? Now, the way we can work out the area, remember they've done something times by 7 and got an answer of 63. So we can undo this timesing by 7 by dividing by 7. So we get the area is equal to, well, 63 divided by 7 is 9. So when they worked out this area, they got an answer of 9. So then the next question becomes, okay, how did they work out the area? When the person was writing this question, what maths did this person do to work out the area of 9? How did they get the answer? Well, remember, the area of a triangle is a half times by the base times by the height. Now I know that when they worked out the area, they got an answer of 9. The half is just a half. Now the base, now the person using this probably used the 6 as the base because that's on the bottom. And when they worked out the height, it's this missing number, this x, that they'll have used. So to work out this 9, this person did a half times by 6 times by whatever the height was. And so if we can undo what they've done, if we can solve this equation, we can work out what this value of x is. So let's tidy up first. We can just do this half times by the 6. A half of 6 is 3. Times by x gives us 9. And again, fairly easy to spot what this is in this case. If we're not sure, to undo this timesing by 3, we divide by 3. So we get that x is equal to, well, 9 divided by 3 is 3. So we get an answer of x is equal to 3. Good. Okay, so the other way we could have solved this, which again requires you to be a little bit more confident with your algebra, but it's probably a little bit quicker, is to substitute everything into this formula straight away. And we can swap this a for something a little bit more useful. But the first step's exactly the same. We're going to do the volume is this area times by the length. Oh no, that's not an L, that's a 4. Times by the length. And then, now the area is the area of a triangle. And I know that the area of a triangle is a half times by base times by height. Now, you're probably thinking this is exactly the same as before. The maths is the same, it's just it may be in a slightly different order. So what we're going to do, we're going to swap this a. Instead of writing a, we're going to write a half times base times height. Let's get the volume is equal to a half times by base times by height times by length. And now what we can do is we can substitute everything into this big super formula and then solve to get what x is. So we get the volume is equal to, well, the half stays as a half, and the base is 6, and the height is x, and the length in this case is 7. And the volume, sorry, the answer they got was 63. So let's substitute that in as well. So now we can tidy this up. So if we do a half times by 6 times by 7, well, a half times by 6 is 3, times by 7 is 21. So we get 63 is equal to 21 times by x. And then again, we do 63 divided by 21 to tell us that x is equal to 3. Very handily, we got the same answer. Okay, so 2 slightly different methods to solve these slightly backwards ones. Whichever one you want to do is entirely up to you. As long as you're getting the right answer, the one that makes the most sense for you. I personally prefer the first method, and I think it's a little bit more clear in the thought process. But again, the second method, if you can do it right, is probably slightly quicker. Good job.